afternoon, everyone. Thanks for joining this month's Beyond Our Value, and welcome to all our panelists. We've got a great group of folks that we'll introduce in a little bit. Gonna let people trickle in, and as we do that, my slide here progresses. We're going to talk a little bit about control layers, the fundamentals of building science, and above and beyond that from this great group of folks that design and implement best practices. Probably have learned from mistakes along the way. Love to hear more from them. Talk about moisture, durability, comfort, indoor air quality, and anywhere else the conversation goes. We have interest in learning who our audience is. If you'd like to add in the webinar chat where you're coming from, what your profession or occupation or interest is, a builder or remodeler, just interested, distribution. We get a lot of folks on that side of things as well. And also, how familiar you are with the control layers, with high performance design on a scale of 1 through 10. I'd love to hear more about that. I think we might have some friends along the way here, some folks that are pretty strong in the understanding about high performance design. So we'll skip the fundamentals and basics for the most part, but happy to make this an open-ended discussion for those in the audience as well. We do have Claire Donnelly joining us from behind the scenes, who will be able to field some questions, and we'll try and run those in line if we catch them, or leave a little time at the end of the discussion before we wrap up. So we've got a number of architects, some from the Northeast here, and also manufacturers, builders, remodelers, panel manufacturers. Great group, looks like. So we'll get things rolling. So I'd like to introduce everyone to our panelists. We've got Holly Mumford is the founder and architect behind Hereabout, residential design studio focused in making thoughtful, efficient homes more accessible. With over a decade of experience, she specializes in creating adaptable pre-designed home plans that balance design quality, constructability, and budget, emphasizing warm, livable spaces rooted in sustainability and everyday use. Thanks for joining us, Holly. Glad to have you along.
Hi, everyone.
We'll provide a little bit more information about their websites, where they're coming from in the chat later on. We also have Chris Briley from here in the great state of Maine, principal architect of BRIBURN, award-winning Maine firm known for passive house, net zero, high performance design, certified passive house consultant, co-author of Pretty Good House, a great read. I hear it might be a little hard to get at the moment, but a great read, well worth checking out. Chris is a leading voice in practical, durable, and low carbon residential design, and also co-host of the Green Architects Lounge podcast and founding board member of Passive House Maine. Thanks, Chris. Glad to have you here. Connor Malloy, it's not often that I can say we've got guests north of us here, halfway up in the state of Maine, but professor of design and building at George Brown Polytechnic and an instructor with Passive House Canada, consulting practice, Supernormal Buildability Consultants, focuses on translating design intent into practical buildable assemblies that perform on site. With over 15 years experience across design, construction, and education, Connor brings a hands-on interdisciplinary approach to teaching high performance building and passive house methodologies. Thanks, Connor. And last but not least, Ben Bogie, third generation high performance builder and chief operating officer of Building Performance Cooperative, with 20 years of hands-on experience and blends deep building science knowledge with traditional craftsmanship, drawing on a family legacy of early super insulated construction, has led award-winning low energy projects, and is a frequent speaker and educator focused on durable, healthy, and low carbon homes. Welcome, Ben.
Having me.
So I guess we'll jump right into it. I've got a couple of other slides here just talking about our products. Obviously, very interested in high performance, but also this three-legged stool that we talk about, healthy planet, healthy people. All of this really comes together when good design is implemented in the built environment, no matter what that construction type is. So a little humbled by the crowd that I have to talk with here, because it's really about bringing it all together and looking forward to discussing those things with you all. We are, I feel, a comprehensive above grade solution with solid metrics across the board about carbon storing, about performance, about the upcycling and recyclability of materials, moving towards circularity, focusing on non-toxic solutions, fire resistive materials. And all of that comes together when we talk about control layers, which is how we'll start this and frame this up. We talk about the 4 control layers of water, vapor, air, and thermal control. And I'd love to hear from you folks, when we talk about, say, the perfect wall, when all these things come together. I imagine it's not always perfect when that happens. So if we were to look at the perfect wall and those control layers, building things are often a lot messier. If you have just a simple box, it's pretty easy to come together, or a lot easier to come together. I remember Joe Stieberg once saying that if engineers designed buildings, there'd be no windows, for example. Where does everyone land on these control layers, and what drives these decisions? And maybe a recent project, or maybe something that you've written about in the past. But be interested in hearing from you folks. Maybe Ben, you have something to start with.
Sure. Well, we can go right with what you were saying about the perfect wall there. So the perfect wall, for those that are with us that may not know, is where we place all of the insulation outboard of the structural and air tightness and water tightness layers of the building, keeping them warm and protected. That's Stieberg's perfect wall that he's been teaching us all about for so many years now. To me, my perfect wall is one that's responsive to the project, right? We're asking, projects to do all sorts of things, right? They can be commercial structures, light commercial structures, manufacturing, residential, institutional. They can be on a coast, they can be on a mountain, they can be in a forest. And we're asking them to do all sorts of different things in those different settings. So to me, the perfect wall is the one that we choose that responds best to where that building is and what we're asking that building to do, what its function is. That's how I start finding the perfect wall for that project, right?
Yeah, that's great. And both Chris and Connor, I think, are coming from passive house, at least as far as skills and certifications. And maybe not every project you're engaged with is that level of detail. But what does that perfect wall look like for you, Chris, for example, in the projects that you're producing?
Yeah, it's a lot like what Ben was describing, or I'd say from the passive house background, we were always trying to put more R value of our wall on the outside of our vapor control layer because that keeps it warm. And yeah, so the most recent projects we're doing, we have from our sheathing out, we've got this, timber board. Yay! I mean, we're here with TimberHP, but it really, our office has been like waiting, just like I think everyone who's joined has been waiting for the timber board product to come out, and it's out, and everyone's excited. We're using it, and we have used Gutex as well, but even before that, we were doing Larson Truss. type projects where we're putting cellulose on the outside to keep that sheathing warm. And the whole idea is just to keep a risk-free, mold risk-free wall assembly. And Connor's
Yeah.
probably, you guys are doing similar stuff, I'm sure.
And
Yeah, I can
Connor,
speak.
for you, with your consulting, you're involved, engaged in many levels. What stands out to you in this?
So a lot of the challenge every day is working with teams to figure out what is buildable for them. So there's an expression, what's the best material? It's one that's installed correctly. And for us, passive house or building better or even a pretty good house is an approach, right? It doesn't define what assembly to build, what your enclosure looks like. It's an approach. So we find working with teams, even students in the shop, is what assembly or enclosure can this team best deliver? So it might be based on regional training. You can panelize because you have teams for on-site installation, teams who have experience with cranes. Where I live, that's not really an option for us. Is we stick build a lot of things still. So double stud can make a lot of sense because the core of the structure is very similar. We have a 2x6 bearing wall, and we can vary the depth of that assembly. In other cases where you have teams experienced with doing lots of exterior installation with a commercial background, they don't bat an eye at adding 6, 8, 10 inches of exterior because they understood how to fasten it, how to install windows. So I go back to what's buildable and what can the team do with ease.
Yeah, I love the adaptability and the focus on making it work for that location, for that climate, that microclimate even. Holly, you are coming from a little bit different angle where you're, from what I understand, letting go of that baby really quickly with the plans that go out into the world. How is it for you as an architect, and how you promote best practices when that goes out there to your end customer?
Yeah, great question. I mean, I'll mirror everything that everyone said already. Like, we're starting out from our side, we're starting out with a typical detail that we feel really strongly about, and it's basically what everyone's, said already. We're getting that exterior insulation on the outside of that sheathing, and we've really tried to make that detail flexible enough for people, for builders and clients to look at it and respond to it. But that's our starting point, which is a really nice starting point to like hand off and have a conversation with the builder and with the client about their budget, about their location, and then tweak that detail for the project and have the conversation with the builder before we finalize that set in and share it with them for them to move forward with about what they're comfortable building. And if they've never done something like that before, resources that they can use to feel more comfortable. And if they're not, then we just talk about, okay, we're trying to get to this R value, and we're talking about the air barrier and making sure everyone's understanding all of these important steps, and just tweaking and refining from there. So definitely a collaborative effort, and just making sure nothing's done like in a silo, even if it's a handover project.
That's great. Where do you find from any of you on projects that you're handing off, designing, not building, design and building, consulting on, where along the pathway do you find the greatest maybe potential for missteps or the hiccups that come along, the stuff that you wish you could have caught earlier, or maybe need to catch before something happens? Where in the process, in the construction cycle or design process, does that land for you, Chicky?
I want to be part of the conversation as early as possible.
Yeah.
That
Yeah.
like Holly said right there, one of the biggest things that I frame our work through when working with new design partners on projects is this collaboration.
Yeah.
Right? The way that we get modern buildings constructed is through collaboration, because I grew up in this business, and when I started taking a paycheck from it in the late 90s, you could pick any carpenter from anywhere in the country and put them on a job site, and they'd probably be able to figure out what to do. Nowadays, it's not that case anymore. There's so many materials, so many interactions, so many aesthetic requirements that it's not just a repeatable thing, and we have to work together, because just like Connor and Holly were touching on, it does come down to like what your crew is comfortable with. What is the aesthetic thing that the architect is trying to pull off, and figuring out, well, how do we not only build it, but how do we build it well, right? Connor's point before was spot on, in my opinion. It's not what's the best material, it's what's the one do you think you can install well, right? So, but you don't figure that stuff out unless we collaborate and unless we start those conversations as early as possible.
Yeah.
Gonna say
Definitely. I think
almost.
things fail. Yeah, go ahead, Chris.
Well, I was gonna say when the builder comes on board, that's when everything starts to go. No,
Well, if you
I-
architects could figure out how to actually draw a house that's buildable, we wouldn't be such a pain in the butt.
So it's
Here
just
we go.
it's the implementation, the reality hits. All of a sudden, it's beyond a dream.
Well, it's really like, so imagine like I designed the perfect wall or whatever. We're gonna do some outsolation with timber board on this, and I get a builder who's like, no, I don't. We don't. We do double stud. That's what I want to do. I want to hear that as early as possible, to Ben's point. So it's like when the
Yesterday.
builder
Well,
comes on board and is
yesterday.
able to give their feedback, right? That's when we start adjusting and making changes and start figuring out what are we doing for on the technical side. So, earlier is better.
Mhm.
Sure.
I think too, something that we see is knowing team construction. So teams that do a lot of in-house work, they perform in-house with carpentry. They can construct most buildings, right? They can put the air control layer through the framing. When you have trades here that also subcontract framing is sent out, exterior insulation is contracted by somebody else. It's all those little bits in the RFPs of, well, who does that piece of wrap at the top of the wall under the truss? Who does that piece of membrane under the sill gasket for capillary? It's all those little bits and pieces. So for us, it's the drawing shows this building complete. We see this with students, right? It's all 13 layers. But some of our students and builders think like Lego, right? What's step one? What's step two? What's step three? And how do we show them the sequence so that that piece of membrane is really part of the scope of the interior trade, but the roofer needs it before they drop trusses. So how do we show them that sequence and make sure they're set up for success?
Yeah. It's funny. I think back quite a few years ago. I had more hair on top, and none of it was gray. I was an insulation installer with a home performance-based company, and we did a little bit of everything. We were a whole house in nature, and we got a opportunity, a project with College of the Atlantic. And some of you will know Mark Rosenbaum. And he also was probably less gray at the time, but they
If you
hired
don't
him
know
on.
Mark Rosenbaum, Google that name and read anything he's written.
Yeah. He will challenge your assumptions for sure. But also a great body of work. He was brought on as the envelope consultant, and it was the first time I'd seen anything like that in new construction. And we had a trades huddle. Obviously, this was a college, it was a larger project, but it was accountability. It was making sure that all of the layers at the time, which some people understood on principle, were really understood, and that when the plumber came in or the electrician came in, there were still some continuity or at least awareness of all of those parts. So would love to see that. Is that something that in your work, Connor, that you might engage with at that level, or maybe Chris and Ben, certainly, do you have that ability to be that connected to any of these projects that you are part of?
For us, it's an important thing to talk about with builders, because if we go pull back a second, when you go to Home Depot or a large retailer, there's an aisle for insulation materials. There's an aisle for a lot of exterior water control. But there's no aisle for air control. So air control is a system for us. So we find that it is something that needs to be explained. And we need to make sure that everyone on the team, the person who drew the project, the person going to frame the project, the person going to do any interior detailing, they all understand where they start and leave off for each other to make sure it's connected. Because that control layer starts as something, one material under the slab. In terms of something up the wall, it might be 4 products as it comes around the sill plate, comes up the wall, 3 products at the window. The window's in air. Is making sure that each member of the team really understands that. So we kind of do something called like take 5 for safety with students, with the builders. It's any sub who comes onto the project understands where the air control layer is, what it's made of, and how they might be interacting with it.
Yeah, great.
Say,
Yes,
so like
before Chris.
the air barrier part, like that is, I love how you said that there's no section for that. Is I feel like the air barrier is the most confusing of all the four layers. Actually, it's the vapor barrier that's most confusing, but it's the air barrier that's making it confusing because the air barrier can be any of them.
Yep.
And it's the chameleon. It's the one you need one primary air barrier, but you can have two if you want. You can have as many air barriers as you want, but you also got to know where you're controlling the vapor and everything. So establishing like the primary air barrier I find language wise is a lot more helpful because there's going to be other moments where like, well, wait, this interior thing you want to be an air barrier too. It's like, well, yeah, that's vapor control, but yeah, let's seal that up where it's air as well. So
Yeah, yeah, yeah.
Cool.
We get that oftentimes with Timberbat. What, do you need you need the
Mhm.
paper facing on that like you have with fiberglass? It's like, well, again, it depends. What kind of control layer do you need and what are you controlling? You're controlling airflow because of vapor, because of condensation risk. And again, where you put other control layers, whether they're vapor control layers or weather resistant barriers behind timberboard or over it or both, or you get a little crazy with layers of control as long as they don't work against each other. It generally turns out pretty well, but it's interesting to see with variable perm vapor retarders, something newer in the marketplace. I think I probably used more 15-pound felt than I did anything else in most of the remodel work that I ever did. Still think it works, maybe a little bit lighter,
It
but
does.
certainly
We just don't have
exactly.
old folks around that know how to install it anymore.
There you go. There you
Can
go.
I, Jason, can I interrupt you for a moment and just push on a little thread that I heard there? I think our industry right now, as we are starting to adopt higher and higher performance assemblies on our projects, in a lot of ways is also very much overcomplicating the situation.
Mhm.
Okay. I can't tell you how many times I have details come across my desk from design partners that have like this line and this line and this line and this tape and this sealant and this flap and this thing and folds and tucks and all this stuff.
Yeah.
And it's for me, we're already struggling with the workforce that we have, right? We are in a spot where we don't have a lot of skilled tradespeople, and that layer of complexity scares people away and also sets projects up for failure and risk, in my perspective. And it's not for lack of intention. They're trying to do the thing, but what is happening, I feel, is that we're having building science by product catalog on a lot of projects right now. People find these product catalogs for these variable vapor retarders and all these high performance products, and they're like, oh, we're going to try that one and that one and that one and that one. But nobody's asking like the core principle, like, can we just make the sheathing the air barrier and tape that one thing and not have to do origami? Right. So just that's me starting to hit that grumpy old man phase of my career right now, I fear, where I'm like, we're making this too hard. We're making this too darn hard.
Yeah, yeah. Amen to that. Amen to that. I'd love to hear more about that. I think that's great and sort of where I'm heading with all of this. I love the high performance materials that are available to us. Integrating them as part of a system is another thing altogether. And how much of that do we need? How much of that do we really need? And again, appreciate all of the smart membranes, the tapes, the high performance material. How much of that is critical in your projects, Holly? Are you specifying a particular material? Are you specifying a particular approach?
We, for our typical details that we set out before we talk to the builders, we don't specify any particular manufacturer or specific product. And that's for a reason, because I really want to hear from the builders when we have our onboarding call with them before we finalize everything, like what do you like to use and what's available. For instance, I was on a call last week with a builder and we were just talking about the wall assembly and making sure he was feeling really comfortable with everything. And he was, and it was great. And he was like, oh yeah. And this is very good timing. He was like, I really want to use the TimberHP outboard, like the board for the exterior insulation. And I was like, great, let's do it. Like, that's perfect for this assembly. And I think his willingness to like really want to use a specific product and something that he has used before, then we'll use that information to finalize and just kind of check all the boxes and make sure it's all working together.
Chris, you build beyond residential. Does this change in projects with BRIBURN when you move into other construction types?
A little bit. I mean, so and I gotta kind of put up a big asterisk on this. Like since the pandemic, like we've been doing a lot more residential than we have been commercial, but we're getting back into some of the commercial. But in fact, we're doing a retail shop in Rangeley. It's gonna be kind of like an outdoor center, the Alpine shop calling it, and it's a commercial project, and sort of like we start pivoting, so it's a very voluminous, very large, and it's going to have a large glass front to it. And Harry and I were just having a conversation about the owner wants it to all open up and have customers in and out. It's like, well, like at Bar Harbor, like the door's always open and people are just coming in and out, and in the winter too, and that's not going to work. And like so, like these ideas of like these big garage doors that are going to open everything, it's like I don't think that's going to work. So I mean, so it's like it's like a different mindset about the energy and especially the comfort. You can tolerate a much different comfort range shopping for your Patagonia, jacket than you can, with your shoes off, feet up on the coffee table, having coffee or whatever. I feel a little like I drifted away from the building science there for a second, but like the different materials, and even like sometimes we have to have non-combustible materials when we're doing like multi-story projects that are multifamily or something like that. So yeah, and again, the volume to surface ratio changes that, in residentially single family home, we're looking for an R40 wall. 3 or 4 story multifamily, we're looking for R30, R35. And so you're that, achieving those is a different method.
Chris, can I
I don't-
hit something
Yeah.
that you said there that I think is worth repeating, and that's comfort, right? A
Yes.
lot of the
Sure, yeah.
conversation that we have around insulation we talk about energy, right? Like that's mostly what people are talking about. Like we're trying to keep my boiler from running so much, right? We're adding more insulation, trying to actually keep the air conditioning in the house. But comfort, I think, is one of the biggest ways that I sell performance with clients, right?
Okay.
Because spending thousands to save tens doesn't pencil out for most people. But telling them that for a few thousand, you can be more comfortable in your house is something that all of a sudden, what is the value of comfort? Where's the RO? How do you calculate the ROI on comfort, right? People's metrics change pretty quickly around money when you start asking them that. Or then the next one is like health, like talk to them about insulation through health.
It's true, and I think to a large extent, people are kind of used to the building not being comfortable. They don't know what comfort feels like. They expect their house to leak. They expect the front door to stick after the first year. They expect the basement to be 3 degrees cooler downstairs, and one bedroom is super hot. That one needs a window shaker, and only this room is comfortable at one time. We're kind of conditioned to that. But then our cars perform comfortably. We select comfort. So I think if people can see what it feels like and understand what that means to have within 1 or 2 degrees between basement to top floor, can feel amazing. Glazing that is selected based on the space, based on its orientation, not just as big as possible. Because we talk to clients is, well, what does that restaurant feel like when you go, they've got that cool roll-up garage door? Can you sit beside that at your table in the winter and not take your coat off? Well, no, I can't. Because that's what your house is going to feel like. How to get them to see what comfort could feel like, and then it becomes an easier thing to invest in.
Yeah.
And
I,
even
I
the
think that's
lifestyle
spot
changes
on.
that like shift when you're used to living in a house that is super leaky, or just, yeah, it's not up to the same standards, and keeping windows open all the time, just to get a little airflow, like just simple lifestyle changes that do happen, that people aren't used to.
Yeah, one of the best compliments I ever got from a client, they didn't even know they gave it to me, is we had built a house, a passive house, and it had wood fiber on it. This was 10 years ago. And we went back to visit for some maintenance item or something. And the homeowner said to me, she says, I realized the other day I haven't looked at my thermostat in 4 months.
Nice.
That's a
Very nice.
win, right? Because that's like the building is doing what we want it to do. It's comfortable, it's healthy, it's ventilated, all of those things.
You're
So,
not
yeah.
constantly tweaking the temperature.
Oh, like me in my house, it's like a battle between my wife and I, up, down, up, down. She also thinks if you turn it up, it makes the heat come out faster. So it's great for us with somebody that's nerdy about HVAC systems.
That's how it goes. And, if I am traveling and it's 90 degrees out and 220 in the car, it's going to be, at 65 in no time, because it's got to come out faster, right? It's got to come out. Not the case. Yeah. It's great to hear this conversation about new construction, about passive house. I came back again, past life, retrofit work. Huge amount of retrofit work still available, certainly in the Northeast, but all the way out to the West Coast, because we haven't built things right the first time around many times, or we've cut corners or just didn't understand. Always opportunity to improve existing structure and some great benefits to that. But that was the big struggle 10, 15, 20 years ago. How do you sell that? And first and foremost, it's, well, we've done the assessment on your home, and this is where we see the inefficiencies, and here's the cost payback. I know it doesn't look so good because it's going to take 15 years to pay for all of this stuff, or the savings based on that. But when you spin that around, you start talking about the comfort and also the durability, the performance of the assembly. Then we're talking about things that matter a little bit more, I think. It's great to hear that.
Really covered.
What about moisture and something to add, Chris?
Well, I was going to say, yeah, and it's really a conversation like kind of what Ben was saying about comfort, that you have with that client about what they're trying to get out of that renovation. I mean, sometimes we get hired to do, to just kitchen reno or whatever, and it kind of snowballs into a much bigger thing when we start talking about the windows and insulating this new addition. How much more do we want to affect the rest? And there's no prescription for that. That is a deep conversation you have with the client, of figuring out what they want to do and accomplish, and all those conversations that as you guys have been talking about comfort and those tangible things. They're going to spend a lot of money. It will not pencil out. It just won't. Renovations are it's you're doing it to improve your lifestyle more than you are to save money. So.
Yeah, and I think like beyond comfort even, and you noted it, Ben, but just creating a healthier environment too. I think we talk about, but I've started to talk about that more with clients recently and really push that, because I thankfully really, really like a lot of my clients, and I'm like, I want you to be healthy, so it's easier to like pass on that enthusiasm and pass on that motivation with something that they can really also understand so easily, along with the conversation of comfort.
Yeah.
When what other we've talked a lot about the complexity of all of this, about integrating all of these concepts, how it's discussed. Is there, are we finding, like Chris, you mentioned Larson trusses in the past. Are you building in new ways now from when you started, or proposing new ways now or different ways now? versus when you started earlier on in your careers?
Massively, yeah. Well, I have a much earlier than say Connor does, and Ben even, So like yeah, it used to be, you did double stutter, you strapped on the inside and used, well, I mean, even it was like you used cellulose. Well, that's a fancy new insulation instead of the pink stuff. That's how it used to be. So like but now everyone is rolling their eyes, what, like, yeah, grandpa, we know that. So what's the new stuff? I think like I think about like the membranes and tapes, like we were talking about vapor barriers and things. It's like the membranes and the menu of membranes and tapes is huge now. Whereas I think even 10 years ago, you start saying, well, try this white glove tape, the Sega, this one, thing. And now it's like we have in our specs, and maybe this is a tip for architects as we start doing this, but we say like there's a Sega suite, there's a Proclima suite, and we say use this tape for this tape for this tape for this. So like we just have a chart for like in the specs, you're doing your tape to try to take, because I can imagine being a builder and you're looking at the drawings and you see a tape this to that. I have to go figure out which one of these many. And so that complexity it's awesome that we have that kind of control, but again, keeping it simple is a real quest.
Yeah.
I was just going to share, I find for us builders and students right now, we find that the windows and doors can be the thing that really shifts what enclosure or what kind of wall we look at. Because with a flange window, a lot of our local builders want to build a traditional stud cavity, insulate that stud cavity, and a flange window sits at the sheathing. When we start to push into using exterior insulation, the first thing that changes is, well, what's the window detail look like? If we add 2 inches, okay, maybe a conventional approach works. We'll just run strap around the opening. What if we go to 4? What do we have to do now to get that window hung out of the framed opening? So we found we started bringing in, like a European flangeless window. It doesn't have to be European, but a flangeless window. That window can now shift into the middle of the wall. So a midi, you can shift all the way into the bearing wall, shift out in some kind of window buck. And finding a team to start to get their head around what bucking a window rough opening can look like gives them a lot of different comfort with exterior insulation only, a hybrid approach with a right amount of exterior insulation, deep stud walls, because that window and door now just shifts back and forth, right? You're kind of freed. Once you're freed from the sheathing, you can do whatever you want.
Make big punchy dramatic openings and nice shadows, or you can push it out to the
Yeah.
face and have it look like every other house on the block if that's what you're after.
You can cool your pie inside on the deep window well or outside.
If you have office cats, sometimes a deep windowsill is a wonderful thing.
Good.
My house is very old. I have very little windowsills for my office cat to sit upon.
Hence the extra desk.
Can I, Jason, I think I heard you headed somewhere before that I feel is worth talking about, and that's moisture and
Absolutely, yeah.
moisture management, because anytime we're talking about insulation, we need to be talking about moisture management, because it's the control layers: water, air, thermal, and then vapor in order of importance, right? We handle water first to keep the bulk water out of the building. That's good flashings, good WRB systems, good drainage, right? Proper roof slopes and overhangs. You heard me, architects. I said overhangs on the building. Then we move to air control. Like, air control is the next most important thing, and that works hand in hand with the thermal to do moisture control in our assemblies, right? So we're going to get something like 300 times more moisture into an assembly because of air movement than we ever will just from vapor, natural vapor movement through that assembly. So that means we have to pay very close attention to that air tightness to keep moisture out of the building. The third lever that we have is the thermal, right? This is where insulation can really become a critical part of moisture management in the building. That's either we're stacking enough of it on the outside of the assemblies so that those assemblies are staying warm and they never hit dew point, right? It's like putting the koozie on the outside of the beer can. that principle. And we have to be aware of that in relationship to how much we put on the inside. Like Connor was touching on before, hybrid assemblies, where we have insulation on the cavity and on the outside of the assembly. The thing is that right now our industry doesn't do a very good job of understanding how much and where, and actually our codes say two different things in different places in the code about how much and where, which is a problem. And the reason for that is when we get these ratios wrong, we end up in the position which we are currently in with our industry, which is where we have an explosion of moisture issues and mold growth problems riddling our buildings, right? Just Holly, like you said, I really like my clients. Like, I want them to be healthy. I don't want to put together an assembly, number one, that's going to have lawyers at my door when it explodes with mold. That's concern number one, to protect my business. But number two, I don't want to put my, those families at risk. I met somebody who was a pulmonary epidemiologist recently. He says, oh, I float this idea around that the reason we have an explosion of childhood asthma in our country is because of polyethylene vapor barriers in the walls since the 60s and 70s. And it traps moisture, and we've got mold growth. Anybody that's experienced an existing building, taking them apart, knows how scary some of those assemblies are on the inside. And he said to me, he said, no, there's actually clinical pediatric data that shows that those things are correlated. And there's a growing body of data that's showing that they're directly connected, right? And the reason I say this is this whole thing that we're putting together here, this air control, this water control, and all this can have a dramatic impact on the people that live in the house. But if it's at a state where it's bad enough that it's affecting the people living in the house, it's headed towards being bad enough that it's actually destroying the building, right? This is when we get moisture accumulation in roof assemblies and wall assemblies that turns to mold. The mold turns to rot. The structure turns to oatmeal. And then we have lawyers.
A lot of unhappy folks. Yeah, that I think that confusion in at least the US code with vapor control, air control, thermal meeting the thermal metrics required for the split wall system. I think that it kind of plays out in the fine print that gets missed sometimes, unfortunately. But I think it's a critical detail. Breathability overall, I think, with these assemblies, when we talk about moisture and allowing that to do what it's going to do and release, I think is a critical part. And one of the better trends I've seen in the industry now have to be part of that with wood fiber insulation. There are other materials on the market, and certainly it's just a systems approach in the end that makes that work. Any other above and beyond all these control layers? And thank you, Ben, that was very well put, bringing all that back together again. But what for you folks drives it? We've talked about comfort, about indoor air quality, about health. Are there other aspects of it that really move you or the people that you work with above and beyond those control layers?
Yeah, it's amazing. We're 45 minutes into a TimberHP sponsored thing, and we haven't mentioned carbon, not once. And it's amazing because that's kind of like the reason everyone's got all the excitement around us. I mean, because we've had the perfect wall, So also we kind of we've had polyiso, and we've had even XPS back in the old days or something like that to wrap a building with. But now we have something that's better, that's carbon sequestering, and that's the exciting piece about it. It's vapor open and carbon sequestering, and so it's and so like your
What does that
normal
mean,
wall.
Chris? What does carbon sequestering mean?
Oh, thank you, Ben. So oh God, yeah, I gotta back way up. So the embodied carbon, everyone hates to say embodied carbon, of course. Upfront carbon is a better way to say it. It's the carbon that is released into the atmosphere, making a product, basically, or to get that product, well, out of the gate, as they say, ready for you to pick up and purchase. And so having having a building that is emitting carbon in its production of all the materials, makes it so no matter how net zero or energy saving your project is, um, your building's already day one, you know, release that carbon into the atmosphere. And so we have a product that is made from a biogenic material. A tree grows, it builds itself by sucking the carbon out of the air. And you have this material, and instead of burning it or letting it rot and release that carbon, you store it in your building. And that's the secret to sequestration. You're sequestering that carbon, and others are going to argue, yeah, but one day that is going to come out. But yeah, there's a time value to that, storage now where it's an emergency. And so we've got a product that is doing that. And, we use Beam. Beam is an online free with donation suggested calculator. And, we've created a sample building that's a 2,000 square foot building, and we've run all kinds of things, materials and assemblies. And so, like, if you take like a fiberglass, OSB, regular wall, in this assembly that we've got, that it basically represents 4,000 kg CO2e out in the atmosphere, and that's the equivalent to a year of the average person driving. If you just switch the insulation to an exterior fiberboard and either a cellulose or a timber bat, then you sequester 6,000. So that's a difference of 10,000 tons of carbon dioxide. So you're actually sequestering. You're taking away more than a year and a half of driving, as opposed to adding a year and a half. I find having driving as the
Good one.
output of your carbon makes sense. So, hooray, biogenic materials.
I just happen to have a slide deck that we had Chris Magwood and Jacob Verkruzen, RMI, Beam Tool, big advocate of straw bale construction and other bio-based materials, recently at the ResNet, talking with other raiders about this very thing. And I love this slide that Chris shared, that he's put together for RMI, talking about dynamic life cycle analysis. And that green line represents bio-based materials. You start at this negative space moment so much farther below the line. So even if we equalize out at the end of life and everything's spent at that point, operational has happened and all of that, above the line and below the line, I think that is probably one of my most favorite geeky slides right there.
I remember seeing Jacob years ago. The thing that blew my mind on this, gave a presentation where they had looked at the carbon impact of a passive house versus a code-built house. And it was a passive house that used heavily petroleum-based foams and insulation products. And from the moment that house took occupancy, it would be 150 years before it was having any net benefit to the environment because of its energy reduction from being a passive house. And that was with the assumption that nobody was going to modify or remodel it or change it or repair any part of it in that 150 years. Now you add in the very good likelihood that you're going to repair or fix or reorient or reconfigure that house in 150 years. And it started to be like, oh my God, we should just build code-built houses, which is also not the answer. But the answer is we build good houses with materials that we select mindfully for their impact along with their performance for the building.
I saw Chris Magwood speak. So Chris Magwood was local for us in Toronto, around Toronto, and I saw him speak 70 years ago on this topic, and had kind of an identity crisis. We were building a lot of high performance homes as we deemed them at the time. They had varying assemblies, ICF and others. And we came away from that presentation learning that, yeah, that upfront carbon is a big part of the conversation if the goal is, again, reducing energy demand. Well, for his thing is for what purpose? Well, reducing carbon. So it's okay. We're on the same page. If that's the goal, let's start with that at the very beginning. And it changed how we look at assemblies, products, and looking holistically at the building up front and also in operations. So if you want to check it out, check out Builders for Climate Action, and it's the BEAM tool.
Yeah, good stuff. Good stuff. We've got about 10 more minutes. Want to be mindful of people's schedule and time. There's folks in here. We've had some comments along the way, not too many questions from the audience, but just a reminder, if you do have anything, directly you'd like to add, feel free to drop that in the chat. I really appreciated the conversation. Carbon certainly, we've never outright led with that, going back to that three-legged stool of high performance, which is obviously a deeper bucket or well to pull from when you talk about performance and what are those metrics. Health for environmental concerns or for folks themselves, those that are working with materials, but also those that are going to be living next to those materials all along once that is built. One comment from the chat was, if a structure can last 1,000 years, 150 is nothing. Durability obviously is a huge part of it. Any other focal points for you, for your customers, clients? We talk about above and beyond just the base of the control layers, durability, comfort. I think we've hit on some of the best out there. Anything else come up that you want to add?
I got one, and it's because I don't work for TimberHP and I don't have to be humble on your behalf. But we haven't talked about the fact that TimberHP is bringing back jobs to a state and an area that needs them, and an industry where the infrastructure and the workforce already exists, but was gutted and shipped offshore. So bravo to you folks for, putting your money where your mouth is and investing in our communities and investing in a wood basket that is not doing anybody any good, just rotting in the forest, right? Let's use as much of these natural resources as we can for these building products and push to have more and more of these natural resources used for building products, because we've got plenty of them. Even if we're as conservative, as sustainable in managing them as we can imagine, we have more wood in this country than we know what to do with, literally. So good on you guys for bringing that workforce back and bringing that economy back to an area that needs it.
Really, really appreciate that. I have to say, also humbled by the folks that do the work. I get to be the talking head sometimes. I get to maybe, run down rabbit holes, as very well as well. There's there's an abundance of smart engineers, of operators in this state, in every single other state, and it is a beautiful thing to bring back domestic manufacturing. The multiplier effect, we were just talking about this earlier on a separate call, of using residual materials and what was once lost for other parts of the industry. So want to mention that if you have not heard, one of our early supporters, Robbins Lumber, up here in Searsmont, just recently experienced a very tragic, devastating fire at their facility. This is a family business. They have been manufacturing wood products, and it was great to see the community rally around them, and I'm certain that they'll be back in production in short order with support from this forest products industry in the state. 200,000 green tons are what we plan on processing. There's 2 million green tons in this state alone, just sitting, waiting for something. So anybody got other ideas? There's lots of chips out there. There's no shortage for sure.
Just keeps growing.
It does. It does. Yeah. And it's a story across this entire continent for sure. Anywhere there was paper, anywhere there are trees, there are wood products that are coming from that. I'm sure you know that as well, Connor, up north.
Yep, we got lots.
Excellent.
Maybe I'll just do just a callback. This is my last comment back to what we first talked about, the perfect wall. I think for builders and teams that are nervous about trying or building high performance or building an airtight building, there's a lot of things that feel like they have to change in the way that you rough in and insulate and put on your air control layer, water control layer. If you do want to try a perfect wall and put the majority, if not all, of your insulation outboard of the sheathing, the framing's the same. The way you then rough in your stud cavity is the same. Your plumber, electrician, HVAC technician don't need to be air sealing geniuses. It goes in the building, right? It's not rocket science, it's building science. And if we can start to transition towards more outboard, the rest of the building gets a lot easier. We can test the building for air tightness before the exterior installation's on, fully roughed in, airtight building, then clad it. So if you're unfamiliar, build some mock-ups with your team, ask your suppliers, is this possible? Can we try it?
Yeah, that's great. I really appreciate that. One of the things we thought about asking everyone was just one habit in the industry that you'd love to change. I think that is a great opportunity just to explore something a little bit different. Anybody else want to chime in on one part of the building envelope or about production build that would make a difference?
I was going to chime in right before you said that would make a difference. Because I was like, I was just going to do a quick PSA because I had, and I think Ben, you got the same text from the same window guy who saw because they're doing outsolation, they're building out bucks, and the leather wrap is being wrapped into the buck, and then it's being taped, and that is not the way one should do it. And I happen to know from talking to him, it's coming from high performance builders and architects drawing them that way. And I will be the first to say, I've got details that have that shown right here in the office, and we don't do that. We're not supposed to do that. So, and that is because there's a fabric. If you got Sega or Blueskin or something like that, it can actually wick moisture in, and so you're actually inviting some moisture in. You're probably fine on the jams, but the head, you're bringing that. You might be bucking that water in, and still you might be holding that water. So cut that out, let the tape do that part, and then seal your window to that tape. So that was my PSA for you building science geeks that wanted to get something out of this. Go back to your drawings and go, oh, shoot, how are we drawing that? Check that out. So
that was your PSA for more PSAs, pressure sensitive adhesives.
Ooh.
Really good, Ben. Yeah. Oh, and with that, we're done now.
Well, again, I really appreciate great conversation. Appreciate y'all joining. I believe we've got contact information or at least websites for each of you in the chat, and certainly reach out to us at TimberHP if you'd like to connect and don't have anything direct to these great folks here. And on to the next. Thanks again so much, everyone, and have a great rest of your week.